Hi. In today's lecture, I'll introduce quiz and exam, how to take those quizzes and exams. I jot down here already. Let's look at this one. We'll take 2 quizzes in this semester and 2 exams. We'll use this URL to take those quizzes and exams. blackboard.sejong.ac.kr. You can access this lecture in the Blackboard. After that, you can see this menu in the left side, homework and Wireshark quiz exam. All of them will be used in the same menu. All quizzes and exams, those are based on open book and open website. Thus you can refer to any materials, but the exam time and the quiz time, that will be very short, because we should proceed in past mode to prevent any cheating. Thus we'll proceed in test mode. Thus the time will not be enough to report to them. Okay, this is the practice quiz test that will be available in this month, September probably 18th. That will be available to prepare quiz and exam. You can take as many times as you want. That is mainly for preparing. Thus that is practice quiz test. But these points, 5 points, that will be applied to the final grading. And the questions are 5 questions will be asked. Those are mainly about the chapter 1, and you should solve in 3 minutes. In past mode, you should proceed. And this is the main quiz test. First one will be in this October 16th, Friday, in the morning, 11 and 11:06 for 6 minutes. If you are starting late, then there will be some subtraction. After 3 minutes, you are starting after 3 minutes, then your points will be subtracted. After 5 minutes, you start so late, then your points will be 0. That is mainly to prevent cheating in this special situation. From the last experience in last semester, and midterm exam, that will be in this October 23rd, Friday, and whole number of questions will be 25, and the time period will be 11 until 11:20. For 20 minutes, you should solve 25 questions. Also, final exam, that will be in this December 18th, and Friday same time, and also 25 questions in 20 minutes you should solve. And also similarly, you should proceed in very fast mode. Thus you start late, then there will be some subtraction after 5 minutes. After 15 minutes, your whole points will be 0 point. Thus be careful about that. That is mainly to prevent from any cheating from the previous experience in last semester. And these points will be 100 points, and that will be the 30% of the final grading, and also that will be considered as 30% for the final grading. And this one will be added up together, and 10% will be considered for the final grading. And more detailed direction in the report to that information in the Blackboard, and especially in this announcement menu, and also briefly in this homework and Wireshark quiz exam menu. You can refer to this detailed information and direction. I will explain a little bit more about the scope of each test. First, about this practice test, the scope will be, as I mentioned already, from the chapter 1, and about the lecture and the PPT. From that contents, I will ask 5 questions. And about this first quiz test, the scope is here. in chapter 1 and 2, lecture contents, especially PPT and some contents which I explained in the during lecture. And this second quiz, after midterm exam, before final exam, the scope will be about the chapter 4 and 5. And about this midterm exam, the scope will be chapter 1, 2, and 3. About the homework and the Wireshark and lecture using the PPT and 7th edition, that book contents will be asked together. Also some supplementary video clips and some animation I introduced already in the supplementary website. About this final exam, the scope will be here, chapter 4, 5, and 6. Same like this: homework, Wireshark, PPT, lecture, and also video clips and animation in the supplementary website I explained already. Also, those scope will be announced in this announcement menu, also in this homework and Wireshark quiz exam here, but here briefly. In this lecture, we learn about application layer. Application layer is the top layer among 5 layers in the TCP/IP protocol suite. Okay, in this chapter, this one is composed of 7 sub-chapters. First, we'll learn, probably in this lecture, first one and the second one. First one is about the principles of network applications. Next one is about web and HTTP and other application protocols, about email and domain name system. That is a kind of application protocol in application layer. And the P2p, that means peer-to-peer applications, and the video streaming and the content distribution networks we learn later. And the socket, finally in this chapter, socket programming API we learn with UDP and the TCP examples. Let's look at this goal. We will learn about the conceptual and implementation aspects of network application protocols. There's the transport layer service models we learn, and also we learn about the client-server paradigm and also P2P paradigm and the content distribution networks. We learn about the protocols by examining popular application level protocols, for example, HTTP, hypertext transfer protocol and file transfer protocol, simple mail transfer protocol, and domain name system. Those protocols we learn. And to create network applications, we need to understand the socket API. API means application program interface. Let's look at some network applications. For example, every day we are using email and web service, and sometimes text messaging and remote login, P2P file sharing, multi-user network games, streaming stored video, YouTube, Hulu, and Netflix. Those are all related to this application layer protocols. And also this VoIP, voice over IP, for example Skype, and real-time video conferencing, and SNS service, and Google search, for example, and so on. To create the network application, we need to write the programs that is running on different end systems and communicate over networks. And for example, web server software communicates you to a browser software. our browser software, that is a kind of client program, and this is server program, and they are interacting. We learn a little more in detail later. We don't need to write software for network core devices. Network core devices are these routers, and we don't need to write software. Let's look at this one. Network core devices do not run user applications. Here, mainly the layers relate to this network core part. That is 3 layers, and the application layer is top layer and 5th layer, and usually for that kind of application, we don't need to write software running in these network core devices. Network core devices do not run user applications, and applications on end systems allows for rapid application development propagation. Here, those are end systems. The application layer protocols are running in this end system. Also this one, end system. This is a kind of server, and also your smartphone and also your notebook, those are running application layer protocols we learn. Here, these applications are running here. This is called application layer. You can see this one is 1, 2, 3, 4, 5. 5-layer protocol suite. TCP/IP protocol suite is 5 layers. And this application layer protocol and this application layer protocol, those are interacting. And we learn how they are interacting. Before that, let's look at some architecture. We can categorize into 2 groups. One is client-server architecture. Another one is P2p architecture. Those are possible application architecture. And first one, let's look at this client-server model architecture. Server, usually in this client-server architecture, server is running always. There's always one host, and this one is holding permanent IP address to provide proper service to the clients. And usually those are located in the data centers for scaling. And let's look at these clients, like your smartphone, like your notebook. Those are communicating with the server, and they may be intermittently connected. And they don't need to be running always, and may have dynamic IP addresses. This one may have permanent IP address or dynamic IP address, it doesn't matter. But server, to provide the proper service, this one should have permanent IP address if possible. Do not communicate directly with each other. In this server client-server model, they are not directly communicating with each other, but P2P model, they are communicating directly. In advance, I'm introducing P2P comparing to this architecture. Let's look at P2P architecture. The no always on server. That means server may be intermittently running, and sometimes it is not running, and sometimes it may be changed to client. And let's look at this one. Arbitrary end systems directly communicate. Anyone can communicate with any other device. Those are called peer. Peer means equal level. Peers request a service from other peers, provide the service in return to other peers. And that is self-scalability. And new peers bring new service capacity as well as new service demands. And these peers, all those are peers, these peers are intermittently connected and change IP addresses. And thus, that is very complicated and complex management required. And let's look at how processes are communicating. Process means program running within a host. within same host. Two processes communicate using inter-process communication. That is called IPC, defined by operating system. And processes in different hosts communicate by exchanging messages. Here, this one is explaining a little more about the clients and server. User client process is the process that initiates communication, and the server process is the process that waits to be contacted to provide a requested service. Aside other aspects about that, applications with P2p architectures have client processes and the server processes. Let's look at a little more in detail later after learning about the socket concept. The socket. Think about our electrical socket. To use electricity, we can think some socket to use computer network services. Process sends and receives messages from its socket. Through this socket, we can send message and we can receive through this socket. And this socket is very analogous to door. And through this door, we can send process. Sending process shows messages outdoor through this. And the sending process relies on transport infrastructure on other side of door. This is transport infrastructure to send properly to other side, opposite side processes. So let's look at this again. Sending process relies on transport infrastructure on other side of the world to deliver messages to socket and receiving process through this infrastructure. This is called door, and that is called socket. In this chapter, we are learning about this socket. Usually, this one is controlled by application developer, and this one usually that is controlled by operating system, embedded already in the operating system usually. Thus we are calling using some proper API, and that is called network application program. Usually network application program developer is doing that. Also we need to understand addressing scheme, and this one is explaining about the addressing processes using some identifier. To receive messages, process must have some identifier, and host device has unique 32-bit IP address. You can think IP address. Think about your computer in the university or in your home. To use internet, you should provide some IP address, or automatically you can provide. Anyhow, that device needs IP address to use the internet. Question is, does the IP address of host 1 which process runs suffice for identifying the process? The answer is no. That is not sufficient. Many processes can be running on same host. Think about your computer, your notebook, or even in your smartphone. You can run many application processes, and they are running together. If your smartphone or if your computer that is holding IP address, then how we can differentiate between those different processes? We need other identifier to differentiate them. Let's look at this identifier. Identifier includes both IP address and port number. We need extra information to identify, that is port numbers. This one is associated with process 1 host. For example, every day we are using this port number. For example, every day you are using HTTP protocol, and that port number is actually 80, and the server is using that port number 80. And to use the mail server, the mail server is using the port number 25. Thus, we need more information except this IP address. Thus, IP address as well as this port number, if we are combining them together, that is called the socket number, that is ID. For example, to send HTTP messages to this university server and web server, we need this IP address of that university, and to provide some application that is web servicing application, we need some other port number as other extra ID information. 80. Thus, we need those information to identify properly. Okay, application layer protocol defines protocol. This one is defining types of messages exchanged. For example, request response. We have different kinds of messages. Also, this one is defining message syntax. What fields in messages and how fields are delineated. Syntax. And the message semantics, meaning or information in fields. Those are defined in this application layer protocol. Also, even in other layer protocol, those are similar one, but others are defined properly. Rules for when and how processes send and respond to messages. Open protocol, let's look at. To make it standards of the world, we need to follow procedure properly to make it standardized worldwide, worldwide standards. Usually that is defined in the RFC, request for comments. The full name for this acronym is request for comments. During the standardization activities, that specific protocol activity, that work is called request for comments with a certain number. And open protocol is allowing for interoperability, thus we need worldwide standards. For example, HTTP, SMTP, those are already standardized in the world. Proprietary protocols, instead of this is a kind of closed protocol instead of this, that is opposite concept, and this is owned by a specific company, and that is called proprietary protocol, Skype. And Skype is owned by Microsoft, and that is Microsoft is owning this protocol. That is called proprietary protocol. That is opposite concept of this open. What transport service does an application need? We need to get data integrity. Some applications, for example, file transfer, web transactions require 100% reliable data transfer. Depending upon that application, the requirement, that requirements are a little bit different, and this one is explaining about that. Other applications, for example, audio can tolerate some loss. If we can hear properly, even though that elimination of some audio, that means some, even though there is some loss, we can tolerate. Timing. Some application require some strict timing, but some applications doesn't need to provide some strict timing. Depending upon that application, the requirements are different. Some applications, for example, internet telephony, interactive games, a kind of a real-time application, those are requiring a low delay to be effective. In terms of throughput, sometimes if we are sending some file, or if we are receiving or sending some video file, then if possible that should be fast enough. Then some application, for example, the multimedia, require minimum amount of throughput to be effective. Other application make use of whatever throughput they get. That is called elastic. It doesn't matter. That is not strict to that requirement. Another application requires some security. For example, your bank transaction application, and to send some information, then that should be very secure. Encryption does, and also data integrity, those are required for this security requiring application. We need to provide that, and thus we can learn this table. This one is explaining about that applications, different applications, and depending upon that application, the requirements are a little bit different. Depending upon the loss and the throughput, time sensitivity, those are different. The requirements are different. Transport service requirements, common applications. Let's look at this file transfer. Let's look at data loss. In that case, no loss is required. And in terms of throughput, as fast as possible, that will be good. But even though that is slow, it doesn't matter. Throughput, that in terms of that is called elastic. Time sensitivity. In terms of time sensitive, that is not sensitive to the time. Email, similarly, no loss and elastic and no time sensitive. And web documents, similarly. And the real-time audio video application, this one is requiring real-time application, real-time audio and video, and that is in terms of data loss tolerant. If that is providing proper speed to hear or to watch, and time sensitive. If that is tolerable, then acceptable, that is for that scope, that is time sensitive, this range. Stored audio and video, this one is loss tolerant, similarly to the above requirements. And interactive games, that is loss tolerant, and in terms of time sensitivity, that is sensitive to the time. Text messaging, there should be no loss. And in terms of throughput, elastic, flexible. In terms of time sensitivity, that is very time sensitive, but within this range, sometimes yes, sometimes no. Internet Transport Protocol services. We can differentiate the Internet Transport Protocol services, and there are two kinds. One is TCP service, another one is UDP service. Depending upon that, we have different protocol. That is TCP, the another one is UDP protocol. TCP service, this one is providing reliable transport between sending and receiving process, and TCP is more reliable. That is flow control providing and congestion control, more complicated and more complex protocol. And this one is okay. Let's follow this one. Flow control, sender will not overwhelm receiver, and congestion control, throttle sender when network overloaded. That is called congestion control. Later, in other later part of this, in other chapter, we will learn about this congestion control. This is one of the major control functionalities among TCP protocol functionalities. And this one is not providing timing, minimum throughput, those are not guaranteed, and the security is also not, that is not provided. Initially, when these protocols are defined and developed, those are not considered at all. Later, depending upon our requirements, those are being required, but initially those are not designed and not developed considering that requirement. And this TCP is called connection oriented. That means similar to the traditional telephone service. Traditional telephone service is providing connection, and this one is similar to that. And the setup required, and setup, that means the establishment of call and call disconnection, those are required between client and the server processes, like our telephone call signaling. That is called connection oriented. Okay, UDP service. Comparing to this TCP service, this UDP service is providing unreliable data transfer service between sending and the receiving process. And this UDP service does not provide the reliability, flow control, congestion control, which are provided by this TCP service. This one is not providing that. That means this one is very simple protocol, and the protocol software is simpler than TCP. Also, this one is not providing timing, throughput guarantee, security, or connection setup. Then why we need this UDP? Depending upon the requirement, we need some simpler protocol. For lightweight protocol, we can use this one. For example, internet applications, we can have this kind of applications. Depending upon that application, we are using different transport layer protocol. Email is using TCP instead of UDP. You should memorize this one. I may ask in the quiz or exam. Remote terminal access, telnet, for example, this command or program, application program, is using this TCP. And the web, every day you are using HTTP protocol, this one is using TCP. And also for this file transfer, FTP protocol is using TCP. For streaming multimedia, for example, YouTube, HTTP, they may use TCP or UDP. Later, we may observe with our Wireshark program or real-time transfer protocol. Internet telephony, this one is also using TCP or UDP. Depending upon the requirement, a little bit different, but mainly for this one, they are using TCP. And later, we learn a little more in detail about this. And also in the Wireshark lab, we can understand better. Securing TCP, TCP and UDP, as we learned in the previous slide, no encryption. Initially, those are not considered at all. Thus, clear text password can be sent into socket and traverse internet in clear text. Thus, we need a secure socket layer, and this one is providing encrypted TCP connection for security and for data integrity. Endpoint authentication we can provide using this protocol. And this one is located at application layer. And the application layer, that means on the top layer. Applications use SSL libraries, and that is talking to TCP. There's above the transport layer protocol, application protocol. In application layer protocol, this SSL is located in that application layer. And SSL socket API, and this one is using clear text password sent into socket traverse internet encrypted. And mainly those security issues are discussed in the chapter 8 in the 7th edition. Let's move to the next subchapter, that is explaining about the web and HTTP. Every day we are using this web service, and that means we are using HTTP protocol. Thus it is a little bit easy to understand comparing to others. Web and HTTP. First, a review. Web page consists of objects. Object means think about your JPEG image and other YouTube video. Those are all objects, and even simple text. And object can be HTML file and JPEG image, Java applet, audio file, video file, and so on. Those are all called objects. A page consists of a base HTML file, and this one is first loaded, this base HTML file, and embedded URL in this base file. Those objects are brought, which include several reference objects here. Each object is addressable by a URL. For example, URL means Uniform Resource Locator, and this like this. First, protocol name, after that, this host name, and the domain name here, and some path name. Finally, some file name. That's called URL. Let's look at HTTP overall picture overview here. HTTP is Hypertext Transfer Protocol. That is the full name for that. Here, Web Application Layer Protocol, and this one is requesting. Think about your application, your web service, web requirement, and you are sending this HTTP request message to the server, and then server is responding properly. PC is running, and the Firefox browser or Google browser, Chrome browser, any browser. Browser is the program, software, and the client program that is learning that HTTP protocol. This is called client server model. This one is client. Your PC, if you are using a smartphone, that is called, or PC, those are called clients, client devices. And those are interacting to the server. Server is providing service. Client, for example, browser, that requests to receive using HTTP protocol and displays web objects. Server, that is the web server here. This one is sending using HTTP protocol objects in response to request. This one is using TCP instead of UDP. And this client initiates, that means the browser program initiates TCP connection to server. At the time, the port number is 80. That is worldwide standard. Server accepts TCP connection from client, and HTTP message is exchanged between browser and web server, between this client program and the server program. Through using that HTTP protocol, that messages are being sent and received. Those are exchanged. After finishing, after completion of the access of that proper information and proper procedure, finally that connection will be closed. Here, in terms of state, HTTP is stateless. That means server maintains no information about past client requests. Other information about that, protocols that maintain state are very complicated and complex. Anyhow, we are not using that state. To maintain that state, that will be very complicated. Past history must be maintained. And if server client crashes, their views of state may be inconsistent, must be reconciled, renegotiated. HTTP connections, we can make two groups. One is non-persistent HTTP, another one is persistent HTTP, depending upon that persistency. And most one object sent over TCP connection connection then closed. This one is not patient. Downloading multiple objects require multiple connection. Connection setup and disclose. Connection setup, close. Connection setup, close. Those are being repeated. In the persistent HTTP, patiently, this one is holding and using that single TCP connection for other multiple objects between client and the server. That may be more efficient and effective. Actually, we are using usually, and this one is providing better performance, persistent HTTP. But anyhow, we need to understand, this one is explaining some concept about that. First, even though we are not using usually non-persistent HTTP, suppose user enters some URL here, and let's assume this one is containing 10 JPEG images, 10 objects. Then this one is requesting, and this one is server is providing. This is client, and this one is requesting, and the server is responding. And the port number is HTTP is using 80. Thus, this one is of course 80, and through that, this one is accepting connection, notifying clients, and there are some interactions between them. This is client and the server. HTTP client, this one is PC or your smartphone, this one is server. This HTTP client sends HTTP request message containing URL into TCP connection socket. Thus, this one is connection setup. After that, this one is sending HTTP request message through that established connection socket. And the first one is base HTML file, and the other objects are embedded there. Thus, first this one will be brought by, and that will be sent by the server. HTTP server receives request message and forms a response message containing requested object and sends message into the socket. There's next interaction is like this. After that, the server is closing TCP connection, even though there are many other remaining objects to be sent. Non-persistent, that is, not patient. Then HTTP client receives response message containing HTML file, simply just a single file, and after passing that HTML file, it is understanding and finding 10 reference or JPEG object. Then the other requests, those are iterated and repeated. The steps 1 and 5, 1 through 5, those are repeated for each of the 10 JPEG objects. And in terms of the response time, that is a kind of performance issue. And how long does it take? That is important in terms of the performance, because we are getting some experience. Depending upon that performance, we can feel better or not good. We can feel about that internet speed. Real time round trip time. This round trip time, this RTT means, that acronym means round trip time, and this is defining the time for a small packet to travel from client to server and back. HTTP response time. Think about this image, and this one is explaining some time, elapsed time, and this one is time axis. Also, this one is time axis. This one is the client side, this one is server side. This means interaction, and you can see this one is going in this way, and you can see some time difference. That is the elapsed time to arrive there. And also, this one is sending some response message, and it is going in this way, and the time, that is called elapsed time. And if we are measuring the time first initiate TCP connection first, and after that receiving then this one is connection setup. There is no file received, and this one is sending request file. After that the connection setup, this one is requesting file, and it takes time to be there, and it is responding properly, and also it will take time. If we are measuring the time, then that is called the connection setup time. This one is file transferring time. Also inside here some internal time delay will be happening. There's always the slight difference, and that is meaning the time delay. Finally, this one is receiving file. Okay, let's follow this one. HTTP response time, 1 RTT to initiate TCP connection. That means this one. And 1 RTT for HTTP request, and the first few bytes of HTTP response to return, this one. And this is file transfer time. This is very slight time. And then that is persistent HTTP response time. And here 2 RTT. This is 1 RTT, 2 RTT plus this file transmission time to get just a single base file, base HTML file usually. And to make it completed, this one should complete using the following procedures. Non-persistent HTTP issues. This one is requiring 2 round trip times per object, and that is not efficient and not effective in terms of performance. And also this one is a kind of OS overhead for each TCP connection, because all operating system is taking care of that. Browsers open parallel TCP connections to patch referenced objects. And TCP, about the TCP here, but the persistent HTTP. This was using TCP, and the server leaves connection open after sending response, and the subsequent HTTP messages between same client and server sent over that opened TCP connection. Client send request as soon as it encounters a referenced object, and this one is reducing the whole delay time as little as 1 RTT for all the referenced object. Thus, we can use this request message to understand better. 2 types of HTTP message. This is actual message, and you can observe using the Wireshark program and during your Wireshark lab. 2 types of HTTP message. One is request, as we learned, and another one is response. HTTP request message format is like this. You can observe in your Wireshark lab. This is request line, get, post, head commands. This one is get command, and some URL here, and some HTTP protocol and the version number. This one is simply carriage return and the line feed. And after that, some header lines here, and what kind of browser applications program is being used in user side, client side. And this one is header line. The other lines are here. Language, about the language, about the encoding scheme, and this is a acceptable character set, and this keep alive. That is means persistently alive. That is implicitly meaning persistent. We learned in the previous slides. And the connection keep alive. This one is persistent. HTTP request message. General format is like this. Method, get or post, and the space, URL, space, version, carriage return line feed, as we learned. And after that, header lines here, carriage return line feed. And this one is entity body. This one is header part, header, but this one is the main body part. Uploading form input, we can use two kinds. One is post method, another one is get method, and also that can be called URL method. Post method, web page open includes form input, and input is uploaded to server in entity body. That is called post method, and that header, HTTP header field may be used for that. But URL method or get method, input is uploaded in the URL field of a request line. Think about your internet address in your browser on the top, and you can see this kind of the domain name and some others, and those are using get method. This one is parameter, variable, and name and the value pair. Name and the value pairs are following here. Name and the value pairs. And we can see two kinds of method types here, depending upon the version. Several kinds here actually. Those are two versions here. Get post head, HTTP 1.1, and in this new protocol, newly in those commands are added, put and delete. And but mainly those are being used more frequently instead of these, even though those are supported by this version. Mainly those are being used. This one is this one can be used to upload file in entity body to pass specified in URL field, and also delete can be used to delete file specified in the URL field. But usually these commands are being used. Let's look at HTTP response message. Previous one was request message. This one is response message from the server to the client. And this one is about the status line. That means protocol status code and status phrase. This is code. This one is the explanation about that. And header lines also here, but different information. Date and the server. This one is made by server and sent to the client. And about the content, when that was modified, when is the last modified time, and the length about that contents, and also this keep alive, connection keep alive. That means this one is using persistent method mode. And after that, the contents which is being sent by the server to the client, for example HTML document, HTML file, those are following. About the response status codes, this one is status code, and this one is explaining about that phrase. Status code appears in the first line in server to client response message, and if that is 200, then means it is okay, successfully. Request succeeded, and requested object later in this message. And 301, that means that the server is moved permanently. The web page that holding server that is not here, moved permanently. Requested object moved, new location specified later in this message location. And 400, sometimes we may see this one, that means that is bad request. Request message not understood by the server, and that is not found in this server. Request document not found on this server. And after this, there are maybe more, but let's finish with this one, 505. That HTTP version that is not supported. We can implement HTTP using telnet, like a simulation. We can implement in the client side using the telnet. We can implement HTTP like that, but it is different from HTTP. But we can provide this command line, and we can get some app service. But this one is so inconvenient, so we don't need to use in this way. That is just for reference, and you don't need to worry about that. You don't need to memorize that. Telnet and some URL and some port number, that means that is HTTP. Opens the TCP connection to port 80, that is HTTP server port. And get HTTP method, get HTTP request, and we need to provide this complicated and inconvenient command line, and we don't need to do that. Just for reference, you can leave this one, and you don't need to use this one in real world because this is so inconvenient. By typing this in, you send this minimal get request to HTTP server, and you don't need to do that, just for reference to understand how it is working. Look at response message sent by HTTP server, and you can observe using Wireshark tool to look at the captured HTTP GET response.